Just more basic functions.
I'm cooler than him.
Yes.
Than he is.
All right. All right. Welcome back. I'm with Sarah here. We're doing Algebra 2 trig and stats. And today we're talking about functions. We're reviewing for a test. Yes? Reviewing for a test?
Nah, this is just review.
Just general review of functions. Okay.
Yeah.
Functions review. Oh, yeah. It says it right at the top. Functions review. All right. So to review what a function is, well, what I'm going to do is I'm going to color code these because it's fun. I'm going to make the f function blue. I'm going to make the g function red. And I'm going to make the h function yellow.
Okay.
So that we can see what we're doing. So h of x plus minus g of x is the same as h of x minus g of x, which is red, minus g of x. So what I do is I write out h of x and g of x. G of x, when I do write out g of x, I want to make sure I put parentheses around it because I'm subtracting it. And when I subtract things, I always have to be careful to distribute it in. So there's h of x, that's the red one. There's g of x. H of x is x cubed plus 3.
Mm-hmm.
And so now I just add these together. And when I add them together, I need to make sure that, like I said, I distribute that negative in. So distribute, distribute, distribute. So all these signs change. And now I can just add like terms. There's a x cubed. There's only one of those. There's an x squared right there. So minus x squared. There's a minus 2x. Minus 2x because I had to distribute the negative in. And then the only thing I really have to, the only like terms I have are a positive 3 and a positive 1, which add up to positive 4. So there's your answer. So for number 2, it says g of 2 or x plus 2. So for this one, what I'm going to do, as I write my g of x out, I'm not going to actually write out the x's. I'm going to just leave a big space so I can plug in what they want me to plug in, which is x plus 2. You understand how I did that?
Yeah.
And then just simplify. Don't forget x plus 2 squared means x plus 2 times x plus 2, which is going to give you x squared plus 4x plus 4. If you don't understand that,
yeah, I know how to do that.
Do this on the side and you'll see. Foil it out on the side. And you'll see that you get that 2x and 2x, which is 4x in the middle there. Plus, distribute that 2 in, you get 2x plus 4, and then of course, minus 1. So now let's add like terms. Again, I've got an x squared. I've got 4x plus 2x, which is 6x. Those are like terms. And I've got 4 plus 4 minus 1, which is positive 7. And there's your answer. For number 3, f of x. So all I'm doing, again, I'm taking negative 2 and then I'm going to plug in. Notice I'm using parentheses and I'm going to rewrite my f of x. But instead of, as I'm writing f of x out, instead of writing x, I'm going to put a parentheses where I would have written the x. And that's because I need to make sure that I plug in the 3x instead of x.
Mm-hmm.
Now I simplify this, so this equals negative 2. I'll leave that on the outside for now. Minus 9x minus 2. Did I do that right? I'm just checking to make sure I didn't miss any signs or anything. Now I can distribute this negative 2 in. So that equals a positive 18x because I'm multiplying, and a positive 4, and that's my answer. Now at the bottom, we're finally getting down to the fun stuff. Okay. All right, so g of f of x. Now this is a different function than a different operation than you've used before. For this one, I'm going to plug one function into the other.
Yeah.
So I'm going to take my g function and I'm going to write it out. I'll use the red. But instead of writing out the x, I'm going to put a big space in there to hold where the x is going to be, because what am I plugging in? Let me color code this too. What am I plugging in for that? This is g of
F.
F is the blue one. G of f of x. So I'm plugging in f of x into here, and f of x is negative 3x minus 2. Negative 3x minus 2. Every time I see an x, instead of writing an x in there, I'm writing f of x, which is negative 3x minus 2. Follow that?
Mm-hmm.
And then, of course, just simplify it. And this is where people make mistakes all the time. But remember, this is negative 3x minus 2 times itself.
Yeah.
Plus, distribute that in, negative 6x minus 4 minus 1. So when I multiply these out, when I FOIL this out, that, and that, there's going to be 4 terms. It's going to be 9x squared
Mm-hmm.
plus 6x plus another 6x plus 4 plus negative 6x minus 4 minus 1. Now let's add like terms. I only have one x squared term, so that's it. I have 1, 2, 3, and hey, those cancel with that, so that's nice. This is just plus 6x. Oh, look, gone, right?
Yeah.
So I just have 1 minus 1 left over. Unless I made a mistake, that's right. Got it?
Mm-hmm.
All right, you want to try the next one? Tell me what you're right.
Okay, so for this one, you're right. F. Colors H. Yellow.
Yellow.
H. Negative 2. So then you do negative 3. I'll leave a gap. Minus 2. Right? Am I doing that right so far?
So far, so good.
Okay. And then that.
You could do that if you want. Yep. Just be careful with this. Make sure you have parentheses around that. Right? Because that goes in. So really what you maybe should have done first, Sarah, and what you're doing is totally fine, but you could have just simplified. You could have just figured out what h of negative 2 was and then plug that in for f.
Okay.
That probably would have been easier, but that's essentially what you're doing here, right?
Yeah.
Because you're first going to have to simplify this.
Yeah.
So what's negative 2 cubed?
That's a good question.
It's a negative times a negative times a negative. So it's negative 8, good. And then what's negative 8 plus 3?
Negative 5.
Negative 5. Now what's negative 5? Now you're plugging negative 5 in for f, right?
Yeah.
So what's a negative 5 times a negative 3?
15.
Mm-hmm. And
So
what's 15 minus 2?
13.
Perfect.
Okay.
See how that worked?
Mm-hmm.
So this last one is f times g. It's not function composition, it's just multiplication. So for this one, all you have to do is take 2 times and then do f of x times g of x.
And so wait, for this one, would it be easier just to solve and do multiply f of x by g of x first and then multiply it by 2?
Yes, it would be.
Okay.
It would be easier. You don't have to. You could multiply the 2 into the f of x first if you wanted to, but I think that would be easier, what you just said. So it's negative 3x minus 2 times, oh, I'm going to need some more space here, times x squared plus 2x minus 1. Oh, maybe not. And now you have to just make sure there's going to be 6 different terms. That and that, that and that, that and that. And then you take the 2 and distribute it into all the rest when you're done. So let's do that real quick. I'm going to do it like super fast. So negative times, this is going to be negative 3x cubed. I'm going to multiply that here now. That's negative 6x squared. Multiply it here now. That's positive 3x. Now I'm going to take the negative 2 in. Negative 2x squared minus 4x plus 2. And now let's add like terms together and all that kind of stuff. And then let's just multiply the 2 in when we're done. Okay. So we got, we've got x cubed, negative 3x cubed, but times 2. So negative 6x cubed. Got it? We have negative 8x squared times 2 is negative 16x squared. Got it? We got 3x minus 4x, which is negative x times 2, which is negative 2x. Got it? And 2 times 2 is positive 4.
Quick question. Where did you get the cubed from?
The cubed came from negative 3x times x squared.
How the heck does that make a cubed?
Well, how many x's are there? What's negative 3x times x squared?
Oh.
It's negative 3x cubed. Yeah, those are the little tiny things. Those little details are the things that people struggle with often.
Yeah, okay. Cool.
Good?
Yeah.
Make sense?
Yeah.
All right, was that it or do we have another one?
There's a few more.
All right. Find the domain and range of the graphs. All right, remember domain, scan, horizontal or vertical line scans. Where is it going to touch it? At negative 2. Where is it going to stop touching it?
1.
At positive 1. Got it? So the domain goes from negative 2 including it, because there's a dot there. There's a solid dot there.
Yeah.
Right? To 1 not including it.
Yeah.
Make sense? So that's the domain. And the range, for the range, we do the same thing, but we go a horizontal line scan from bottom to top. Where's it going to start touching?
1.
At 1. And where's it going to end touching?
5.
5. So it's from 1 inclusive to 5 inclusive, because both of them are included in the graph, or at least it appears so.
Yeah. This one would be the domain.
Yeah, give it a shot.
The negative infinity. Oh god, I suck at drawing the infinity thing.
It's all good. Just do a snowman.
Infinity.
Just two little zeros.
Okay. 4 with that.
Good.
Range. 4 with that.
Nope. Remember,
Oh,
you're scanning. Scanning.
0.
Yep.
Would it be negative infinity?
Nope. Because remember, you're scanning.
Oh wait, yeah.
Think of it as scanning. It seems silly, but I literally still do it. When I think of domain and range, I literally draw like imaginary lines from the bottom to the top and ask myself, where is it touching the graph? Yep, you got it. How about the next one?
Is this a trick question?
No. What's the domain? Where is it not gonna touch the graph?
Infinity?
Yeah, it's never not going to touch it. So the domain is just all real numbers, negative infinity to positive infinity.
Oh, okay.
And the range, scan it.
Is negative infinity
Mm-hmm.
1. Or wait, what is that? That's a 4. Looks like a 1.
4, yeah.
Oh, wait, would that be a bracket or parenthesis?
It looks like it touches it. So bracket.
All right.
All right, you ready for number 10?
Yeah.
Graph both on the same coordinate plane. All right, so how do you find the inverse? Well, if you're given a point, if you're going to graph it anyway, you might as well do it like this. This is the easiest way if you ask me. Let's just plot some points in here. And we really only need 2 points, but just to be safe, let's do 3 points.
Okay.
Now remember, this is I'm plugging in whatever I want. It's an independent variable. Whatever I can plug whatever I want in for x. There's no domain restriction on this. There's no no-nos. So what am I going to plug in? What would be a good number to plug in for x?
1.
Okay, would 1 be a good number? Let's think about it. Is that going to be a nice number if I plug in 1 for x?
No.
Do you like fractions?
No.
No. So what number could I plug in instead of 1?
2.
How about 2?
Yeah.
If I plug in 2, then those fractions cancel out and I just get -1 plus 3, which is 2. Got it?
Okay.
So I would pick 2. What other number can I pick?
4.
How about 4? If I click 4, what would I get?
1.
Good. So 4, 1.
Okay.
All right. Now, wouldn't it be nice to have 0 in there? Isn't it always
Yeah.
good to have the x-intercept if possible? I'm sorry, the y-intercept if possible?
Yeah.
Yeah, it is. And what would you get?
3.
3. So 3. Good. And then the line, then go ahead and draw it in. Nice job. There's your line. Now that's the function f of x. So let's color code that. Circle f of x
Where?
in blue. Circle like your f of x equation. There you go. Now to find the inverse function, which they didn't want us to find it yet. It said then find the equation of the inverse. So we don't even know what the equation is yet, but I'm going to show you why it's really easy to graph this and you don't need the equation to graph it.
You just reverse it, right?
All you do, nice job. All you do, and I'm going to use red.
Okay.
All you do is you reverse the x's and the y's. You flip them. 2 and 2, 1 and 4, 3 and 0.
Oh gosh. What the heck? Oh my god.
You draw lines better than me, so.
Oh, don't want to erase it. What the heck? Nope.
Nope. Nope.
Nope, not that one. Not even close. Oh my god. Good enough.
There you go. Close enough. Good enough. All right. So now let me show you the really cool thing about this. I'm going to draw in the line y equals x. See that line?
Yeah.
The perfect diagonal line. The red and the blue line are reflections of each other over that line.
Oh.
That is another quality of inverses. That is another characteristic, I should say, of inverses. Okay. So now let's talk about how you actually find the equation of the inverse. Remember what you do? You change the x and the y,
Yeah.
and then you solve for the new y. So to solve, I'm going to subtract 3. And then I'm going to multiply by -2, because that'll get rid of the -1/2, right? So multiply by -2 plus, -2x plus 6 equals y. And that's your inverse. F inverse equals -2x plus 6. And if you look up here, well, that sure is exactly what I have. There's 6 up there.
Yeah.
And it's got a slope of -2. Goes down.
Nice.
This has a slope of -1/2. And they're inverses of each other. Got it?
Mm-hmm.
All right. Was that all you had today?
That is it.
Awesome. Well, hey, thanks for coming by. And hey, all you people out there in YouTube, whatever you find this video in the future, or maybe you're watching it live today, no matter when you found it or where you found it, come back for more someday. In fact,
Yeah,
you can have your
do
own
it.
one-on-one session with the one and only Mr. Dwyer if you go to my website, 204tutor.com. Bye-bye for now. Don't forget to subscribe. What else
Leave
am
a
I supposed
like
to
down
say?
below. Leave a comment.
Leave a comment, leave a like down below. If you put a comment, don't expect me to answer it, because I usually don't, but I'm so sorry. Bye-bye now. Have a wonderful